Hello everyone, welcome to the next lecture on the calculus. Today I will explain you how you can solve the problems related to the partial derivative. Myself Dr. Harish Garg. You can follow my YouTube channel where you can find the playlist of the calculus. In this playlist you can see the various topics are explained with the help of the easiest way. You can follow my YouTube channel and subscribe my YouTube channel so that when I uploaded my next lecture you will get the notification. Now, in this lecture, we will see how you can define the partial derivative. So firstly, I can just simply use the notation. I can define that del x upon del x is defined as the partial derivative of f with respect to the x, keeping y as my constant. Fine. Similarly, if you define del f upon del y, then in this case we called as keeping x is my constant. Then partial derivative del f upon del x, it is also be denoted by fx, or if you say del f upon del y, then we can also say this is my f of y. If you find the partial derivative at some particular point, then we have denoted the notation del f upon del x at the point x naught y naught, or you can use this notation, otherwise all have the same meaning. Now, how you can define the partial derivative? Firstly, the partial derivative of f with respect to the x at the point x naught y naught is defined as limit h approaches 0. Now, since in this partial derivative we have keeping the y as a constant, so first of all I can write this function y as my constant, that is y is my same point. Fine. And then we can define the corresponding x is x naught plus h and my x naught divided by the difference of this h. Fine. This is the way you can define the partial derivative of the x, keeping y as my constant. Similarly, the partial derivative with respect to y is again the limit h approaches 0, and since we are talking about the partial derivative with respect to y, that means the x is my constant, so I can fix the value of the x at the point x naught. Fine. And y naught is my difference of h. Now make sure that this partial derivative exists only when the limit is my existence, and as I mentioned you in my previous lecture of this limit, when the limit will be existence if it give you the unique answer. Fine. Now what is the geometrical meaning of this del f by del x? Suppose I consider the function as f of x comma y, which is denoted by the z. That means we are talking about the surface. So now I can define on the x, y, z axis, and this is my surface. Consider the point of the x naught and y naught. Say this is my x naught, this is my y naught. The corresponding point is my x naught, y naught. The corresponding value of the function f at the point of x naught, y naught. So this is the value corresponding to the point x naught, y naught. So this point, basically this point I call as a p, whose value is my x naught, y naught, and the value of the z is my f of x naught, y naught. Fine. Now corresponding to the fixed value, because we are talking about the derivative with respect to x, that means y is my fix. So if I consider y is equal to y naught, that is my plane. Fine. Corresponding to this plane, the value of the z is my f of x comma y naught. So I consider, say this is my value of the z at the point x comma y naught in the plane y is equal to y naught. Then what is the meaning of the del f by del x? If you define the tangent corresponding to this point, if I define the tangent, this is my tangent line. Fine. And this tangent line is defined as the partial derivative of f with respect to x. Or if you consider this is my y, and if I consider the x naught plus h comma y naught, the corresponding point is my again this, fine. And if you draw the tangent line, that will be my del f by del x. You can see I consider 2 point x naught and y naught. The corresponding point is my p. This red line is my tangent line, which is drawn on the point p. So that means the slope of the curve z at the given point in the plane y is equal to y naught, that's a keeping y naught is a fixed, is known as the partial derivative of x with respect to x. And the tangent line, whatever the tangent line you have drawn, is always passes through this point P, and the slope is given as del f upon del x. Similarly, you can define the partial derivative of f with respect to y. That means if you have the curve x, y, and z, in this case we are keeping the x to be the constant. I called x to be the x is my constant. Again, you can see x is equal to x naught is my plane. Then again, if I say this is my surface of the z is equal to f of x naught y naught, corresponding the point of x naught, corresponding the point of y naught. The value of this is my yz plane. Fine. When you take x is equal to x naught constant, then the plane will be in the yz plane. So then you can define the tangent point corresponding to the x naught y naught is called as the rate of change of this point P is known as partial derivative of f with respect to y. Now what we have observed, corresponding the same point P, we can obtain the two different tangent. One tangent is with respect to x, second tangent is with respect to y. Fine. Now this partial derivative with respect to x is defined the rate of the change with respect to x, keeping y is my fixed value, or you can say y is my constant. Similarly, del f upon del y represents the rate of the change, keeping x is my fixed value, that is x is my constant value. Now look at this example. I will tell you the two different methods how you can find the del f by del x. First, with the help of what is the meaning of the del f upon del x. Find corresponding to the function f. What does the meaning of the del f by del x? That means y is my constant. Fine. So if you consider y is my constant, the partial derivative of x square is my 2x. Since y is my constant, so 3y is my constant outside, partial derivative of x is my with respect to x1. Because y is my constant, so partial derivative is my 0, 1 is my 0. So partial derivative with respect to x is 2x plus 3y. Similarly, you can find the partial derivative of f with respect to y. That means x is my constant. If x is my constant, then what is the value of the x square? 0. What is the partial derivative of this? 3x is my outside, y will be my 1, y derivative is 1, this is my 0. So partial derivative with respect to y is 3x plus 1. Now your target is to find the values at the point 4 comma minus 5. Therefore partial derivative with respect to x is my 8 minus 15, which is my minus 7, and the partial derivative with respect to y is 4 theta 12 plus 1, that is my 30. Fine. Now the second method we have used with the help of the definition. What is the definition of the partial derivative with respect to x at the point 4 comma minus 5? So now in this case, make sure your target is to fix the value of the y. I can say the value of the y I can fix as minus 5. Fine. Now your target is to vary the value of the x. It is 4 plus h. Fine. And 4. So that the difference is my h. I can substitute this value. Now this is my x, this is my y. I can substitute this value. This is my 4 plus h square plus 3 times 4 plus h into minus 5 plus y minus 1 minus, what is the value of the 4 comma 5 is a 16 minus 60 minus 5 minus 1. So it's a 6, it's minus 50. Taking the limit as h approaches 0. Fine. Now you can open this bracket, that is a limit h approaches 0. It's a 16 plus h square plus 8h minus 60 minus 15h is a minus 6 minus minus plus 50 divided by h. Now clearly say this is my 66 and 50 plus 16 cancel. H will be cancelled out, so the limit will be h minus 7. Now once you take the limit as h approaches 0, answer is my minus 7. Fine, this is the same as of the previous one. Similarly, you can define the partial derivative with respect to y. In this case, keeping x is my fixed number. So y I have varied. Again, I can substitute this value in the given expression and you can simplify this, you will get this expression. Again, it's a 66, is a 66 cancel out. Fine. Now it is my 13h divided by h is my 13 is the right. So either you can use this first method or second method, that is on your choice. But I will tell you, you can opt this method whenever the function f is my continuous. Fine. And we know that this is a polynomial. Every polynomial is a continuous function. So you can opt this first method for the easy calculations. Look at this one. Again, you can see this function is my continuous because it's a product of the polynomial and the trigonometry part. So I can find the partial derivative directly at this case. Fine. So what is the meaning of that? Keeping x is my constant. So I can use the product rule. So it will be y first function derivative of second function plus second function partial derivative of second. Fine. Now what is the answer of this? Y sine derivative will be cos x into y. Now the derivative of this, keeping x as a constant. So x is outside, y is my 1. Fine. Plus derivative of the y is my 1. So what is the answer of this? Is x into y cos xy plus sine of xy is the right answer of this problem. Look at this case. Again, I can find the partial derivative with respect to x. Basically, this is my del upon del x of this. So I can use the product rule or I can use the division rule. That will be y plus cos x whole square. It is y plus cos x into del upon del x of 2y minus 2y del upon del x of y plus cos x. Fine. Now you can substitute the value. It is y plus cos x because with respect to x, keeping y as a constant. So once it's a constant, the derivative is 0. Into what is the partial derivative of y with respect to x? 0. Cos is my minus sin x divided by y plus cos x whole square. Now it's a 0. It's my 2y sin x divided by y plus cos x whole square. Fine. Similarly, you can find the partial derivative with respect to y. It is also denoted as fy. Again, I can use the product rule. It is y plus cos x whole square and this one. Now since you have to taken y with respect to y, so keeping x is my constant, partial derivative of 2y is my 2 minus with respect to y is 1 with respect to y, so it's a cos of x is my 0 divided by y plus cos x whole square. Now if you open this bracket, 2y will be cancelled out, so the answer is 2 cos x divided by y plus cos x whole square. Look at this another one. Always remember student, whenever you have the function is given in the form of the cases like of the f1, f2 and so on, you always apply the definitions to compute the partial derivative. Now your derivative is to find at the point 0, 0. How you write that? Limit h approaches 0. Fine. Keeping y as a constant. So y is my fixed number. Fine. Now you can vary the value of the x. Initial value is my 0. It is my 0 plus h and 0 divided by the difference. So that will be f of h comma 0 minus 0 0. Now you can substitute the value. What is the value of the h comma 0? This is a case. I can substitute this value as the sine h cube plus 0 divided by h square. Whenever x and y are my 0 0, the function is my 0 divided by h. So I can say this is my h cube. Fine. Now all of you know, if I write this for you again, this is the limit h approaches 0 sine h cube over h cube, and we all knows what is the limit as x approaches 0 sine x over x. This is my 1, so therefore this limit is my 1. Similarly, you can find the partial derivative of y at the point 0 comma 0. That is the limit h approaches 0. Now keeping x as a constant, so x value I have 0, I can freeze them, minus of 0. Y I can vary, previous value is my 0 plus h and 0. I can substitute the value. What is the f of 0 comma h? So that will be limit h comma 0. So it's a 0 is a h raised to power 4 divided by h square minus 0 divided by h. Fine. So I can write this number is limit h approaches 0 sine of h raised to power 4 divided by h cube. Now how you can do that? First of all, it's a 0 by 0 form. Either you can apply the L'Hopital rule, otherwise I can again use the same formula. Sin x over x is my 1. So I can multiply this quantity by h and multiply by h. It's a sine 4 into h. This value will be my 1. This value will be 0. So the answer is 0. Look at this another case. Again, this is a case of the two cases. So I can found the first part del f upon del x at the point x comma 0. That is limit h comma 0. Fine. Now partial derivative with respect to x, keeping y value is my fix. Fine. Now I can take whatever the value of this point plus of the h, and this is my value of this, so that the difference is my h. Now you can substitute this value. What is the value of the x plus h comma 0? That is a case of this x into y. So y is my 0, so this is 0. When x is a non-zero, y is my 0. Again this is the case. So when y is equal to 0, I can substitute this. It is again my 0. So answer is 0. Fine. Similarly, you can find the second part del f upon del y at the point 0 comma y. That means you have to freeze the value of the x. X is my constant. Fine. And the y is varying from y plus h and y, so that the difference is my h. Again I can substitute this value. X is my 0. Again this is the case. When x is 0, this value is my 0. Limit h approaches 0. When again x is 0, this is 0 over h. Answer is again 0. So this answer is 0. This answer is 0. Now look at this definition. How you can write this value again? Limit. Now it's a y. So that means h approaches 0. I can fix the value of the x. Fine. Now I can vary the value of the y. So y is my 0 plus h and 0. The difference is h. Now you can substitute this value. It is a limit h approaches 0 sine x comma h. So that will be x into h. It is x square minus h square divided by x square plus h square minus y is equal to 0. If you substitute y 0, answer is 0 divided by h. So what will happen if you do that? This h will be cancelled out. The remaining expression will be x into x square minus h square plus h square. Now substitute the limit as h0, it is x square minus 0, x square plus 0. So that will be my x is the answer. Similarly for this case, now keeping x, that's a y as a constant. So y is my fixed number and this is a 0 plus h and 0 there. Now you can again substitute this value. It is h into y. This is h square minus y square over h square plus y square. 0 comma y, when x is equal to 0, it is 0 divided by h. Now you can substitute this limit. So 0 will be there, h will be cancelled out. It's a y times h square minus y square over h square plus y square. If you substitute the h as a 0, answer will be minus 1 into y, that is minus y. Okay, find the partial derivative of this function with respect to x. That means z is my dependent variable, x is my independent variable. So you can partial differentiate this with respect to x. Now, since we have to differentiate this with respect to x, so y is my constant, y is outside, this is z over this, minus partial derivative is 1 over z, del z upon del x. Partial derivative of x is my 1, y with respect to x is my 0. Now can you find this value? Del z upon del x is a y minus 1 over z is equal to 1. So can you find the value of the del z upon del x? I can take the LCM and it will be yz minus 1 is the right answer. This is the first method you can solve this partial derivative. I will tell you the second method also. Fine. The second method we will cover in the next lecture on the implicit function. Once you will watch this implicit lecture, you can see the easiest, this is the most easiest way you can find the partial derivative with. Okay, look at this another one. The plane x is equal to 1 intersect the paraboloid z is equal to x square plus y square. Then your target is to find the slope. Slope means del z upon, now since this is the x is equal to 1, that is my constant value. So that means your target is to find the value of the slope del z upon del y. So can you find the value of this? So your slope is del z upon del y. Can you find the derivative of this? It is my 2y. So at the point 1, 2, 5, what is the value of the slope? Del z upon del y is my 4 is the right answer. This is the first method. Second method is, there is one more method. Second method is, because we have to find the intersecting point, I can substitute the value of the x at the given point. This is the 1 square plus y square, that is 1 plus y square. So therefore the slope will be, because now it's a single variable, instead of taking the partial derivative you can simply take it as the 1 point. So it's a 2y. At this point the value of this is again my 4. Okay, look at this another function, 2x plus 3y minus 4. Again your target is to find the slope of the line. That means the partial derivative of f. So now the first part is along the plane x is equal to 2. Once you are talking about the x is equal to 2, then your slope will be del f upon del y. If you are talking about the plane y is equal to minus 1, that means y is my fixed value. That means your slope will be del f upon del x. So can you find the answer of this? What is the partial derivative of this function with respect to y? 3. Now at the given point 2 comma minus 1, your slope is same. Similarly for the second part, or second method is, what is the second method? You can substitute the value of the x equal to 2 in the given plane. Then your f will be 4 will be cancelled out, only 3y. Then df upon dy is my 3 is the slope. Similarly, corresponding to the y is equal to minus 1, your slope is del f upon del x. And that is a quite similar one. Again, On the plane x is equal to -1, your target is to find the slope. What is the slope? Is del f upon del y. On the plane y is equal to 1, the slope is del f upon del x. So you can find the value. What is the value of the del f upon del y? 3y square. Value of this is my 2x. At the given point -1, 1, I can substitute this value. You will get the answer as 3, and corresponding to the value of this you will get as -2. Okay, look at this another one. The resistance are connected in the parallel, which makes the ohm, and given by this case. Your target is to find the values partial derivative with respect to R2. So what you can do, you can simply differentiate 1 with respect to R2. So you will get this term. So what is the partial derivative of 1 over R? It's a -1 over R square into del R upon del R2. Because we have taken a partial derivative with respect to R2, so 1 over R1 is my 0. What is the partial derivative of R2? Fine, because we all know what is the derivative of 1 over x. Derivative of 1 over x is -1 over x square. Similarly, for this case is 0. Now, can you find the value of del R upon del R2? Minus will be cancelled out. It's a R square over R2 square, or you can also say that it's a R over R2 square. Fine. Now your target is to given the values, add the value of R1, R2 and R3. What is the value of the R? I can substitute in this equation, which is equal to 1 over 30 plus 1 over 45 plus 1 over 80. The LCM is 180, 6 plus 4 plus 2. So that is 12 over 180. So that is 1 over 15. So this implies R is equal to 15. Fine. So I can substitute the value of R is equal to 15. R2 is equal to 45 over square. So the answer is 1 over 3. That is 1 over 9 is the right answer of this problem. There is one more method. Again, the second method you can watch in this lecture of the implicit functions. I hope you can like and comment on this video as well. Now again, you can see these are some cases. So I can apply the definition of this function. How you can solve that? Limit h approaches 0, because we are talking about the with respect to x. So I can freeze the value of the y. Y is my 0. Fine. 0. Then x I can vary from this case. So that's a 0 plus h and 0. So that the difference is my h. I can substitute this value. So limit, this value is my basically h comma 0. This value is my 0 comma 0 divided by h. So what is the value of the h comma 0? This is the case when you substitute h comma 0, the answer is 0, because h into 0 square divided by h square plus 0. When it's a 0 comma 0, the answer is 0. So that's it's again a 0. So that means the limit is my 0 minus 0 is my 0. Look at the second part. Del f upon del y at the point 0 comma 0. Again you can apply the definitions. What is the value of the h? F of 0 comma x. X is my 0. Y is equal to h. Answer is 0. 0 comma 0 is also 0. That is my 0 is the right answer. Now, once we have defined the partial derivative, what can you say about the continuity? We all know if you have the functions, we all know that differentiability implies continuity. Fine, we all know in the single variable. However, if you have the more than the two variables, then there are several functions exist in which fx and fy are existence without the function being continuous. Meaning we have the function of the x and y which is not continuous, but still the partial derivative exists. However, in the case of the single variable, we all knows if the function is my discontinuous, this implies the function is my not differentiable. But in this case, if the function is not continuous, but still you can say the partial derivative exists. For example, look at this case. A function is defined as 0 if x and y are non-zero, product of them 1 if the product is my 0. Can you find the limit, discuss the continuity, and show that the limit is my existence, that is a function is existence. Okay, first of all, can you draw the graph of this? So clearly say this is my x, y, and if I say this is a z, so I have to draw the three axes x, y, and z. So say this is my x-axis, y, fine, say this is my y, this is x, and this is z. What does the meaning of this? xy is equal to 0. That means either x is equal to 0 or y is equal to 0. If x is equal to 0, that means this is a line. If y is equal to 0, that means this is a line. That means whenever the line passing through the axis, the line will be this case. You can see the red blue line. And this is a line L1 whenever xy is my non-zero. That means x has some value, y has some value. This is the graph of this function. Now, can you find the limit of this function as xy comma 0? So clearly say along the line y is equal to x. What is the value of the fxy? 0 except at the origin. Because on the line y is equal to x, say 2 comma 2, it's satisfied by this property except the origin. Similarly, at the point 3 comma 3, the function value will be my 0. Once the function will be 0, what is the limit of this function? Because fxy is 0, so the limit is my 0. Fine. Now, second point. Does the f is continuous? Now, what is the value of the 0 comma 0? F of 0 comma 0 is my 1, but you can see this is not equal to the limit of the f of x comma y as xy comma 0 0. We all know when the function is said to be continuous, when limit x approaches a of the fx, which is equal to f of a. In this case, my a is 0 comma 0 and f of 0 comma 0 satisfied this property, and it is my 1 which is not equal to. So what does it mean? F is not continuous at the point 0 comma 0. Look at third case. Now again you have the two different cases, so I can apply the definition of this f of del f by del x at the point 0 0. Now you can substitute this value. What is the value of the h comma 0? This is the value of the x, this is the value of the y. The product of them is my 0. The function is 1. 0 into 0, 0. The function value is my 1. So what is the answer of this? 1 minus 1, 0. So the limit is my 0. Fine. So this is my 1 minus 1. F h into 0, that is product is my 0. Similarly, the partial derivative of y with respect to 0 0 is my, again 0 into h, 0 into h satisfied this property. So this limit is again my 1. 0 comma 0, again this value satisfied, product of them 0. So sorry, it's a 1. The value is my 1 divided by h. So 1 minus 1 is 0. Again the limit is my 0. So this is my 1 1. So you can see both the limits are my existence. Look at these 17 questions. So you can easily see that these questions are exercise for you. You can try it yourself and let me know in the comment box if you have any doubt. You can see that you have to find the partial derivative with respect to x, partial derivative with respect to y in all cases. For example, in the case of this sine inverse, how you can find the partial derivative of f with respect to x? What is the derivative of the sine inverse? 1 over 1 minus x square. So this is x y z square. Now derivative of this function. What is the derivative of with respect to x? keeping yz is my constant, so yz is the answer. Similarly, you can do for the other cases and let me know in the comment box, are you able to understand this lecture in a nice manner or not. I hope you can like and comment on this video. We will see you next lecture on the chain rule. Till then, you can share this video with your friends. Happy learning always. Don't forget to subscribe my YouTube channel. Best of luck, students. Happy learning.